All right, so I wanted to review your answer for this particular problem. It looks like you missed a step, which is okay. We have to think back to when we're adding unlike fractions, we had to have a common denominator. So like such as if we had 1/2 and 1/3. We would say, all right, 2 times 3 is 6, and that we would be able to essentially so it'd be 3, 6 plus 2, 6, and we'd be able to add those values on the top. And the same thing goes if we were subtracting. So that's the approach that you have to take with this particular problem. So let me show you how I would go about solving this. We're going to start off with our original problem. And the one thing that I do like about this problem is that two of our terms already have a common denominator. So what this means is that I'm seeing in here this x minus 1 and x minus 1. So I can easily take this 5 and multiply the top and the bottom by x minus 1. So always remember that you can always write 5 over 1. And then I'm just going to simply just multiply the top by x minus 1 and the bottom by x minus 1. So let's rewrite this problem again, just so you can see that your denominator of that second term is now going to be the same as the others. Now that they're all the same, the neat thing is that you can just take the top and just solve for x like you normally would. So here is how you do the rest of the problem now. So I'm going to take this top piece, I'm just going to rewrite it just so you can follow my steps. I would then distribute the 5 to the x and the negative 1 in the middle. So you'd have 5x minus 1. And then next, I'm just going to clean up the left-hand side. I want to combine like terms. So you'll end up with 3x. And then I combine the 9 and the negative 5 and get 4. And the one thing I always like to do for myself is underline things as I'm going, so that way I can actually see what is actually similar to each other. That way I can keep track of anything that I haven't combined. The right-hand side is just going to say 6x plus 1. Finally, it's just going through that process. I'm going to just show you step by step just to make sure that you know that if we're going to bring the x's to one side, I always bring the smaller amount of x's to the other side just to keep it positive. I want to try to make sure I have less negatives because I find that that's where the most errors will occur as you're solving. Then you're going to end up with 4 equals 3x plus 1. I'm going to subtract 1 from each side. You'll get 3 equals 3x. And finally, we're going to divide each side by 3 and get x equals 1. So just remember, common denominators is our key with these particular problems. And let me know if you have more questions.